Our topic today is partial fractions. Partial fractions. Let me change my ink. My pen, yeah? Partial fractions. Partial fractions. I'm sure we all remember this. We can still remember this 3 over. We can still remember how to do this 3 over x plus 1 plus 4 over x minus 3. So let's go. That's equal to the LCM of the denominators is x plus 1 times x minus 3, which means 3 times x minus 3 plus 4 times x plus 1, which is 3x minus 9 plus 4x plus 4 all over x plus 1 times x minus 3. And that is 3x plus 4x is 7x minus 9 plus 4 is minus 5 over x plus 1 times x minus 3. That means the single fraction 7x minus 5 over x plus 1 times x minus 3 is the sum of the fractions 3 over 4 x plus 1 and 4 over x minus 3. Basically, the concept of partial fractions is about resolving or splitting fractions into simpler forms. The fractions that are split into simpler forms are called compound fractions, and the simpler fractions into which they are split are called partial fractions. So here 7x minus 5 over x plus 1 times x minus 3 is a compound fraction, while 3 over x plus 1 and 4 over x minus 3 are partial fractions. There are basically 4 types of fractions. Let's write that. Types of fraction. Types of partial fraction. Types of partial fractions. This will help us resolve fractions correctly into partial fractions. A, fractions with non-repeated linear factors. Non-repeated linear factors are the denominator. B, fractions with nonlinear factors that are not repeated. C, fractions with repeated factors, whether they are linear or non-linear. What's important is that they are repeated. And finally, improper fractions. So we start with the first one. Let's take examples of fractions with non-repeated linear factors. A, resolve resolve into partial fractions. Resolve into partial fractions. I think we should just take 2 examples on that. So I got 1. I want to take the fraction we started with, 7x minus 5 over x plus 1 times x minus 3. And that's equal to the factor x plus 1 is a linear factor, which is a polynomial of degree 1. That means the numerator we're going to assign to its partial fraction is going to be a polynomial of degree 0, so to speak. And a polynomial of degree 0 is a constant. So that means, I'm using a to represent a constant over x plus 1. The second factor, x minus 3, is also a linear factor. So the numerator of its partial fraction is also a constant, b over x minus 3. What that means is that if the factor at the denominator is a polynomial of degree 2, that's a quadratic factor, you assign a polynomial of degree 1, which is a linear factor, to the numerator of its partial fraction. You see how that works as we move on. And that means x plus 1 times x minus 3, a times x minus 3 plus b times x plus 1. The denominators are the same. That means the numerators are also equivalent. So that means 7x minus 5 is equivalent to a times x minus 3 plus b times x plus 1. So I'm calling this equation 1x, putting x equals 3 in equation 1. That means 7 times 3 minus 5 is equal to a times 3 minus 3 plus b times 3 plus 1. You can see that 3 minus 3 is 0, and that means the whole of this is going to be 0. 3 minus 3 is 0, 0 times 8 is 0, and we are left with 7 times 3, 21, 21 minus 5, 16, equals 3 plus 1 is 4, 4 times b is 4b, which means b is equal to 4. Now putting x equals minus 1 in equation 1, that means 7 times minus 1 minus 5 is equal to a times minus 1 minus 3 plus b times minus 1 plus 1. And we can see that b times minus 1 plus 1 is going to be 0. Minus 1 plus 1 is 0. 0 times b is 0. So we are left with 7 times minus 1 minus 7 minus 5. That's minus 12 equals minus 1 minus 3 is minus 4 times a, minus 4a, which means a equals 3. Therefore, the compound fraction 7x minus 5 over x plus 1 times x minus 3 is the same as 3 over x plus 1 plus 4 over x minus 3. This method of substituting values for x to obtain the constants is called the cover-up method. But there's an alternative method, which has to do with forming equations and solving them simultaneously to obtain the values of the constants. Let's see how that's done. And that method is called the method of comparing coefficients. So let's see an alternative method. Alternatively, I'm just going to start from equation 1. 7x minus 5 equals a times x minus 3 plus b times x plus 1. I'm expanding the brackets. That's equal to ax minus 3a plus bx plus b. So comparing coefficients. Coefficients and constant terms. Comparing coefficients and constant terms. The coefficients of x on the right hand side are a and b. That means a plus b is equal to the coefficient of x on the left hand side, which is 7. That's one equation. The constants on the right hand side are minus 3a and b. That means minus 3a plus b is equivalent to the the constant on the left hand side, which is minus 5. That's another equation, which I'm naming 2. So I can solve the two equations simultaneously to obtain the values of a and b. Minus 3a plus b equals minus 5. B already has the same coefficient in the two equations, so I can simply subtract equation 2 from 1 to eliminate b. And that means a minus 3a. A minus 3a is 4a. B minus b is 0, so that will be out. 7 minus 5 is 12. And that means a equals 3. Now I can put a in equation 1 or equation 2 to get b. Putting a, let me put it in 1. Putting a in equation 1, 3 plus b equals 7. That means b equals 7 minus 3, which is 4. Therefore, the compound fraction 7x minus 5 over x plus 1 times x minus 3 is the same as 3 over x plus 1 plus 4 over x minus 3 plus 4 over x minus 3, which is the same as what we got when we used the cover-up method. So whichever method however you choose to go about it, you'll always get the same answer. Now, Roman figure 2 very quickly. Roman figure 2. Example 2. That example 2. Did I write example 2? Okay, so let's take another example. Let's take a second example. Example 2. Still on fractions with linear factors, non-repeated linear factors at the denominator. 2x plus 3 over x plus 1 times x plus 4. That's going to be equal to, the factors are linear, so they are polynomials of degree 1, and that means I'm assigning constants to the numerators of their partial fractions. So that's a over x plus 1 plus b over x plus 4, which is LCM is x plus 1 times x plus 4. I have a times x plus 4 plus b times x plus 1. So that means the numerators are equivalent since the denominators are the same. 2x plus 3 is equivalent to 8 times x plus 4 plus b times x plus 1. I'm just using the cover up method. So putting x equals, if I put x equals minus 4, I'll be able to get b. X equals minus 4 in 1. That means 2 times minus 4 plus 3 is equal to 8 times minus 4 plus 4 plus b times minus 4 plus 1, which means minus 4 plus 4 is 0, and 0 times a is 0. So that means the whole of that means I will be left, what I'll just be left with is minus 4, 2 times minus 4 minus 8 plus 3 minus 5 equals minus 4 plus 1 is minus 3 times b minus 3b, and that means b is equal to 5 over 3. Now putting to find a, now putting x equals minus 1. To find a, you substitute a value for x in 1 that will eliminate, that will delete there, that will eliminate b, and then you'll be left with a in 1. 2 times minus 1 plus 3 is the same as, is equal to a times minus 1 plus 4 plus b times minus 1 plus 1. So we can see that minus 1 plus 1 times b is 0. Minus 1 plus 1 is 0. 0 times b is 0. So what are we left with is 2 times minus 1 is minus 2 plus 3. That's 1. 1 equals minus 1 plus 4 is 3. 3 times a is 3a. That means a equals 1 over 3. Therefore, the compound fraction 2x plus 3 over x plus 1 x plus 4. 2x plus 3 over x plus 1 times x plus 4 is the same as a over x plus 1, which is 1 over 3 over x plus 1 plus b over x plus 4, which is 1 over 5. 5 over 3 all over x plus 4. And this is the same as 1 over 3 times x plus 1 plus 5 over 3 times x plus 4. And that's it simply. If you use the method of comparing coefficients, so you get the same answer. So I hope you enjoyed the video, and I hope you enjoyed the video and understood the concepts. It's just as simple as that. And we continue. So we go to the type of fractions. We go to the type with to the type of partial fractions with non-linear factors that are not repeated at denominator.